Let's get crazy. Yeah, let's get crazy. All the people watching from home, you made a big mistake. You can't be here tonight, so you can't get crazy with us tonight. But the rest of you, I hope you will join us in going crazy tonight. Finally, the presentation you've all been waiting for, of course, right? Okay. And finally, another dev session. You've heard from Patrick about collections. I'm going to talk about the errors that may happen when you use them. Talking about DBAs and DBA sessions, there's a lot of DBAs talking here. It makes me wonder, are there any people who primarily call themselves developer? That's reassurance. I mean, actually some normal people in the room. It's great. Okay. Handling errors during DML operations. First, the most important slide, because it's all about me. Who am I? I am Erik. On the bottom right, you can see a couple of ways to get in contact with me. I'm an Oracle ace. I didn't always work with Oracle technology. 600 years ago, I was working in laboratories. Then in 1995, I started working with Oracle stuff. And since 2009, I'm my own boss, because as much as I am an asshole towards DBAs, I'm even more of an asshole to managers. So I became my own manager. Most of my work is in the database, SQL, PLSQL, that kind of stuff. I play around with Apex, but I'm definitely not an Apex developer. Data migrations are things that keep popping up in my work, so that's what I do a lot. And that is also the background of this talk. In these data migrations, you often have to do a lot of data processing, transforming it and getting it into another database. And well, you want to do that as fast as possible, because most of the time you have a limited window in which you can do this. So you usually want to do it with bulk processing, but you also run into errors, and you need to handle that. That's what the basis of this presentation is. If you see a slide that looks like this, with this block there, then it points to a script. I will deliver the scripts with the slides later, so you don't have to start typing whatever. It's all in scripts like this. If you want to run the scripts, then this particular script is what you need to run first, because it creates a couple of objects that are needed. Then one of the things that gets created is this table. It's just multiple copies of the customers table in one table. And at the end, when you're done with all this stuff that I provided, you can run this one to clean it up, and all the objects will be gone again. Why bulk operations? Well, Patrick already said something about that, and I think most of you will already know. But if you do row by row, things are slow. If you do a single SQL statement, it's blazingly fast. But row by row gives you control about each and every row that passes by. A single SQL statement looks like this. If there's one bad guy among these people, all you can do is just treat them as a group. Bulk operations are not the fastest, but they are pretty fast, whatever. And you have full control. So you get more or less the best of both worlds. So how fast is bulk processing? If I do a slow by slow fetch like this, and I run this, then it runs in 5.3 seconds. If I do the exact same thing, but with a bulk collect, it runs in 0.7 seconds. So that's an impressive improvement. If I do a DML without bulk, it runs in 79 seconds, almost 80. If I do the same thing in bulk with a for all statement, it runs in 12.96 seconds. And this may not seem like a lot, but with these differences, if you do DML operations for about 12 hours in a migration, then this adds up pretty much. This is, what is it, about 6-7 times faster? That's a lot. It's the difference between needing 4 days or overnight to do a migration. But what if some of the records do not behave the way that you thought they would behave? Okay. Then you have to do some error handling. Well, during bulk fetching, you're out of luck. There is no error handling for bulk fetching. I can't say that I remember ever running into the need for that, but if you do have it, you're out of luck. There isn't. During data manipulation, we don't have exception handling per row by default. You can't use a save point to roll back to, but we do have save exceptions and log errors. And that basically makes this one not true, because using that, we do have an exception handling per row. Save exceptions, it's when you use that, all exceptions that happen during a bulk operation, during bulk DML, are saved until the entire for all has been processed. So it won't crash the minute it runs into an error. The errors are saved, hence save exceptions. You do that by just adding this save exceptions to the end of this for all. Oh. And then at the end, if errors did happen, you get this exception, the ORA 24381. And that is what you can handle, that exception. We have an example of that over here. We have a for all with save exceptions, and we have an exception when e-bulk errors is a custom exception that is linked to this ORA 24381. And then we can handle it. Inside that exception handler, we have available a pseudo collection, SQL% bulk exceptions. It's a pseudo collection. The documentation says it's a composite attribute that is like an associative array. So it is not an associative array, but for most of the things that you want to do with it, it behaves like an associative array. So I would say forget about that and just think of it as an associative array. It has two attributes, these two, error index, error code. Error index is the number of the DML statement that failed. The number of the DML statement, that is important. I will come back to that a little later. It is the number of the DML statement. And it has an error code, and that's just the code of the exception that happened. The pseudo collection identifies the statements that went wrong. If we have this exception, we can go through this, this collection, just going through all the records that are in there, and we can get the error index and the error code from there. And with that, we can do logging, we can fetch the data of the statement from the original collection with the error index, so we can know what data it was that caused the exception. And if we run this, then it looks like this. Nice. Notice, if we look at it closer, that the ORA error is a positive number, while ORA errors should be negative numbers. So if you want to use this number to get the ORA error message, then you will first have to make it negative. And we may lose information because we don't have the actual error message that occurred at that time that the exception happened. All we can do is ask Oracle what kind of error message is related to this number. So, for example, this one check constraint violated, we have no idea what check constraint. If you have one or two, you will probably easily find out. But if you have 20 check constraints on your table and this is the error that you get, it's a bit of a nuisance. In sparse collections, we have another problem. I said error index is the number of the DML statement that failed. When you look at the name of the thing, error index, it sounds like it's the index number of the record in the collection that failed, but it isn't. It is the number of the DML statement that failed. Error index means, I thought I pressed the button. Error index X means that the X'd record, there it is, the X'd record in the original collection raised an exception. The record, not the record at index X. Example, this is a sparse collection. Suppose index 4 and 7, index 4 and 7 raise an error, then this is what you will find in your SQL bulk exceptions, 2 and 4, because it is the second and the fourth record. And that also is quite a problem when you want to find out what the data was that caused this error. I think they should have at least added another column in here that has the index of the records that you were processing. Solutions to this, well, there are numerous, but I mentioned a couple. You can loop through your original collection. You can make the sparse collection dense, and you can avoid sparse collections. Looping, going through the collection with a count would be this. You go into your SQL bulk exceptions, you get the first error in there. It says error index 2. That means the second record. You go into your collection. You start at the first record. Your count is 1. Is the count equal to error index? No, it isn't. So we go to next, raise your count. Is count equal to 2? Yes, it is. So this is the one that caused the error. We handle the exception. Then we go back to the bulk exceptions, the next record. It's number 4. We go back to the collection, to the next record is to the record where we state the count was 2 is not equal to 4. So we go to the next. Count is 3 is not equal to 4. So next. This is the one, we handle the exception, etc. It's a bit clumsy, but it's a way of doing this. The disadvantage is that you have to do an extra loop through this collection whenever exceptions happen. There's a solution to make the sparse collection dense. You could get into the collection, first record, see if there is a record on index +1. There isn't, so we go to the next record. We take the data in here, copy it to that empty record, delete the original record, rinse and repeat. And now we have a dense collection and we can process this and we don't have the problem with the sparse collection. Obviously, another disadvantage, you have to look through this collection, either always before you start processing it, or when you want to find the data if exceptions have happened, sorry. That last one I would not recommend, because then you would be trying to get your data for your error handling from a collection that has been modified after you have processed it in your for all statement. I wouldn't do that. I would make it dense before processing it in the for all. So when processing it in your exception, you're looking at the exact same collection. There's another one, prevent sparse collections. Instead of going through your collection and throwing away rows that you do not want to have processed in your for all, you could add a column, status, action, whatever you call it. And whenever you want a record not to be processed, you have a status not okay, or an action reject, or yes, no, whatever you want. And then in your for all statement, you add a where clause where this column is okay, or process, or whatever. The disadvantage here of this is that you have extra DMLs that do nothing. They are really fast, because this where clause will immediately see I don't have to do anything with this record, but the DML statement will get executed. So it takes some time. If there's a lot of this in your collection, you're burning time for nothing. But it's a solution. So far, we've been talking about a for all statement on a table, but usually your database does not contain one table. This is what I am usually seeing when I'm doing data migrations. You want to bulk insert clients, subscriptions, deliveries, returns in bulk. And then if something happens, often, not always, but often, you have to clean up what has gone well when something goes wrong, because often there is the requirement that a client, for example, a client, is inserted complete or not at all. So if we insert a client and a subscription and a delivery, and then we go to the returns and something happens, then we need to clean up everything that we already did when we ran into this problem with the returns. Now, how are we going to do that? This one, that one, and that one. Option one, you can look at your foreign keys. You can temporarily change them into cascading delete foreign keys. It's a good option. The return has an exception. You delete the client and the entire tree gets deleted. But for a live database, I think the DBAs here will kill you if you do this. If you have the database for yourself during a data migration, this might be an option, but usually it isn't. And it only works if there are foreign keys. And yeah, I know there should be, but I think we all know that sometimes the foreign keys are missing. And you don't always have the power to enforce that these foreign keys are are made. So if they are missing, then you can't do this. And the logging of these extra rejections require extra queries. This, I think, is the most important one. It requires a very good administration of the foreign keys that you're changing, because no matter what happens in your code, when it's finished, you must have the exact same statuses of your foreign keys as before you began. All foreign keys that used to be non-cascading deletes should again be non-cascading deletes. But you can't just set all foreign keys to non-cascading deletes, because some of them might already have been cascading deletes deliberately. So if you put them to non-cascading, you've got a problem. So you have to have a good administration of this. What am I doing to these foreign keys? What was their status before I began, and have I already corrected that? Okay, the option 2, you can add primary keys of the parent to each collection. If you do that, then for each bulk exception, you determine the primary key of the parent of the collection, and then you can delete all rows with the same parent key. And then if the parent has other child tables, you can step-by-step delete the tree, delete the parent record, and determine the primary key of its parent, and then go through that again. This gets ugly, really ugly. This is okay if you have 2, maybe 3 levels of parents, but if it gets more than that, this gets really ugly. This is the one that I usually prefer. You can create a metadata collection. So apart from all the collections for all the tables that you are going to insert into, you make an extra collection, and I prefer to make that a nested table. You could also make it a global temporary table, whatever you want. You create a collection, and you map each record in each collection to the primary key of the top-level parent. Then for a record that causes an exception, you can get that primary key of the top-level parent, and with that, you can get all the records in all the collections that belong to that same primary key. Example. This could be such a metadata collection. It stores the table name or the collection name, whatever suits you, the index of the record in that collection, the top-level primary key that it belongs to, and its own primary key. Then, this would be an example of such a metadata nested table. I have 2 clients at collection index 1 and 2 for their ABC and KLM. I have 4 subscriptions. 3 of them belong to ABC, 1 of them to KLM, and I have 3 deliveries, 2 of them belonging to ABC and 1 to KLM. Now suppose this one runs into an exception. Then we can just do a query on this nested table to get that row, and it tells me that it belongs to client ABC. With that knowledge, I can just get all the records belonging to client ABC, and I know that I have to obviously delete the client ABC, but also 2 subscriptions. In code, it could be like this. Suppose primary key in the returns table R1534 raises an exception. Then we can get its data from the metadata table like this, from the nested table where table name returns and its primary key is R1534. This record I can join to that nested table again based on the top level primary key. So now it's joined to all the other rows in that nested table with the same top level primary key. I can filter it for example, for the table subscriptions. That will give me the primary keys for that table belonging to the same client. And now I can delete the subscriptions for that client. This is just one simple, relatively simple delete statement for each table that you're processing. So it's a bit complicated with this metadata table. You have to realize how it works. But once you realize that and you create a table, then this is all you have to do to manage that data if something goes wrong. Okay. There's something else too, log errors. There's a different way of handling exceptions. Log errors is a clause that you add to your DML statement. And the errors, if you do this, will be logged in a table with this structure. It's a normal table, there's nothing special about it. The only thing special is that it always has these first 5 columns that you see here: error number, error message, error row ID, operation type, and tag. We'll talk about what it is later. And apart from these 5, it has the columns of the table that need to be logged. The columns that need to be logged will be the maximum length character type. It says varchar2 4000 here, but it depends on your maximum length character data type in your database. Creation of the log table, you can do it manually, and then you have full control of how this table looks. Or you can have Oracle do it for you. It has a function, create error log, accepting 5 parameters. Only one of them is mandatory, and that's the table name. It's the table that you want to create a log errors table for. If you're using extended data types, I would suggest doing it manually. Because if you don't, then all these columns for the entire table will have a varchar2 32K. And that is probably not what you want. Could be, but I think it's a bit much. And under the covers, these columns are treated as a CLOP. You might not want that if you have a table with maximum column sizes of, for example, varchar2 100. This would be a pretty much overdoing it. The parameters, the log table name, you can give it a table name that you invent, can be anything. If you don't supply it, it will have a default name of error $_ and the original table name. And that's with a maximum length of a table name. So nowadays that would be 128. The table obviously cannot already exist. If it does, you run into an error. Table owner, very simple, the owner that you want for the table. If you don't supply it, it's the currently connected user. Table space, likewise. And skip unsupported. If the table contains columns that of data types that are not supported, then by default you will run into an error. By setting skip unsupported to true, it will create the log error tables, but the non-supported columns will not be in there. And these are the unsupported data types: long, lob, p-file, and records, nested tables, that kind of stuff. How do we do it? You just add log errors to the end of a DML statement, just like that. That's all you have to do. But there are some things that are not mandatory. Into log table name, a tag, and a reject limit. Into log table name, here you can tell the statement to which log table you want the errors written. If you don't supply it, it uses the exact same name that is used by the function if you don't supply a log table name there. So the error $_ then the DML table name. Oh, that's that one. The tag, it goes straight into the error tags column in the log table. Nothing else happens with it, it's just inserted into there. And you can use this to identify for which statement these errors were. Reject limit, if more errors occur than this reject limit, then your statement will fail. All the errors will have been logged, but at this point, you obviously decided this is too much. If you have this many errors, we will fail. You can set it to unlimited. It's what often happens. It's by default 0. So that means that the first error that appears, your statement will fail, the error will be logged, and that's it. Example of a simple insert statement on top, and you just add at the bottom the log, sorry, wrong button. The log errors, insert into some table, my insert as a tag, and reject limit unlimited. Advantages compared to save exceptions. Well, it works for everything. As soon as you have a DML statement, you can put this in there. Not just for all statements, any DML statement that you have, you can add this and you have error logging. You have the entire message, not just the error code, so you don't lose information in your error messages. We can have every value of every column, not just the columns that we have in our collection and insert, but columns that might be populated by triggers or changed by triggers or whatever. Everything that is trying to be put into the table is going to be in your log table. What you need to be aware of is there is no automatic cleanup. This table is a normal table, logging gets written to it. As long as you don't throw anything away, the table will continue to grow and grow and grow. That means that old errors, if you don't tag your errors sensibly, old errors might at some point pop up when you're querying for errors for a DML statement that you did a second ago. So you have to have a sensible tagging mechanism. Multiple errors on multiple error tables on a single table are possible. Could be exactly what you want. could even be pretty useful. But it could also lead to one table with eventually 150 error tables, because every developer thinks, I need an error table, let's create one, not realizing that there are already 20 other error tables on the same table. So again, you need to have some standards of how do we work with log errors. The two tables, the error table and the DML table, are not connected in any way. They are just two separate tables. So if you drop one, the other is still there. If you change one, the other is unchanged. So all these things you have to take care of yourself. Yes, your identification of your errors. You've done a DML, you want to know what errors happened, you go to the log errors table. Tag is the only way you can tell which of the errors in the table belong to the statement that you just executed. It is not session specific, so you could also be looking at errors from other sessions and from runs from 3 weeks ago. The structure of the log table, well, it's up to you to keep it in sync with the structure of the DML table. I've said that before. The logging is committed in an autonomous transaction. That's actually a good thing. And the statement will always complete successfully, unless, of course, you have more errors than your reject limit. This means that you actively have to go to your log errors table to find out if any records have been written in there. That's your only way to know if anything went wrong. There is not an exception, as we have with save exceptions, that at the end is raised if any exceptions happened. If you don't actively look at your logged errors table, you will never know that anything happened. It will just finish successfully. You could make your log errors table a global temporary table. That has the advantage that you will only be looking at your errors for your current session and nothing else. So your tagging could be a lot simpler. Then you have to create it manually and obviously as on-commit preserve, because otherwise the commit in the autonomous transaction would throw the record away straight away. The possible advantages, only for your session. So, like I said, your tagging can be simpler. The cleanup is automatic. The table can be truncated if you want to get rid of old errors from a couple of loops ago. You can just truncate it and nobody will dislike you for it. But there are also disadvantages. If this logging needs to be preserved, if you want to have a record of records that did not insert properly, then it means that you will have to pick up these records and you will have to write it to some other logging table. Identification based on tag. If you use a procedure name, well, obviously that's not enough. Anyone can use this procedure name. Anyone can use this procedure, so anyone will have the same tag as you. Session ID, well, it's being reused, so you can't use that either. Datetime, no, two people could run the same code on the same second, so it's not enough either. What I like to do, but it's not the only thing, of course, is to generate a GUID before a transaction, use that GUID as the tag, and once I have done a DML based on this GUID, I know which rows belong to this DML statement. Clear? What if the structure of the DML and the log tables differ? Well, these are basically the things that could happen. There are columns added or dropped. There are the order of the columns differ, or the columns in the log table are not big enough for the data that you're trying to insert or update. Columns, no problem. It's just that the columns that are in both tables will be logged in your log error table. Anything in your DML table that is not in your log table will just not get logged. Anything that is in your error table that is not in your DML table, well, those are just extra columns, they are ignored. Order of columns, as to be expected, is not a problem. But if your columns are too small to hold the data that you're trying to log, well, obviously that is a problem, and then you will run into an exception. Well, if we look again at this multiple DML statement thing that we talked about with save exceptions, in this case, it gets a lot easier. We are inserting clients, subscriptions, deliveries, and returns, and the returns gets an error. Now we can go to the log error table, and in there we will find simply the foreign key to its parent. With that, we can query the subscriptions table to get the foreign key to the client, and now we have the primary key of the client, and based on that, we can simply delete all the records in the entire tree. It's a lot simpler than with save exceptions. This is the performance of it. As it says there, I didn't do this myself. I just stole it from Oracle Base website. It's the performance of for all and the log errors with a direct path insert, and the log errors with a normal insert. As you can see, you can't compare between versions because it's different servers, it's completely different environments. You can compare the different ways of logging, and then you see that doing log errors for non-direct path inserts up until 12 was very much slower than the other two. In 12.1, that got fixed. So if you're on a really old database, then log errors might be impacting your performance pretty much. From 12.1 upwards, that's not a problem anymore. In summary, log errors, you get the actual error message and not just a number. They also store the actual data. With save exceptions, you only have some kind of link with your original collection, which could be problematic if you have sparse collections. Errors logged by log errors are persistent, unless you do it in a global temporary table, of course. But for save exceptions, they are volatile. As soon as your PLSQL code finishes, it's gone. Log errors used for the ultimate bulk operation. You can do a single DML statement, just a simple insert, an update, delete, merge. You add your log errors and it just works. And save exceptions, obviously, only within a for all statement. Yes. This is the thing about the multiple DML statements. It takes quite a bit of coding and stuff if you do it with save exceptions, but if you do it with log errors, it is relatively simple. With log errors, you won't get an exception. You don't get warned about the fact that some records were not inserted or updated or whatever successfully. With save exceptions, you do. So you can't get around the fact that something went wrong. You will have to handle that. If you don't handle it with log errors, well, you're basically screwed because you will never know. Yeah, log errors makes you work to identify the errors caused by the last statement. That's the tagging story. It's up to you to find a sensible way to know which errors belong to this statement. And save exceptions, well, it's all you have. If you have errors, then it must be for the last DML statement that you did. And before 12c, you could run into performance problems for log errors. That was it. Three minutes late, I think. Sorry. Sorry, save exceptions over what? I gave a number of. Yeah, I'll repeat the question for the people watching from home. Is there any reason to use log exceptions and not use log errors? Save exceptions, not use log errors. I think my go-to way of doing it is log errors because it has a lot of advantages. But there's also that disadvantage of finding out which errors belong to the last statement that I executed. Some thought goes into that, and I would go for log errors by default, but save exceptions if you're having a just a bit of simple code. You just try to have a script, whatever, and you just want to handle these errors for this one DML statement that's in there, then yeah, maybe it's faster to just go for save exceptions. And you don't have to create another object in the database. Yeah. You, you're, and I'm sorry, but you're telling me that you can't do log errors in a for all statement. I have been using it. So, yeah. Uh, well, maybe in some versions it wasn't possible. It's possible, but I did use it, so it must be possible. Or I was doing very stupid stuff, and I can imagine that I did. Yeah. Okay. Yeah. Yeah. It sounds right what you're saying. But, I, I, okay, thank you.